everyone, and welcome to the 8th grade virtual session for the mid-module review. At this point, you should have already done a couple of your assignments in Module 1, and you should be ready for the mid-module test. To just give you a little review, I'm going to go over some of the topics, and you should be filling out this reflection sheet. So I'm going to turn off my video now so you don't have to stare at my face while I do this. All right, guys, this is the reflection sheet that you'll need to fill out. The topic for today, we're going to be going over exponents. So you can put that as the topic and put the date you're watching it. And then explain what you're doing in detail when we're doing it on here. I would love if you had a separate sheet of paper and a pencil as well as this reflection sheet so you can be filling it in as we go and also taking notes or doing other problems that don't necessarily have to go on this reflection. You can always pause this in the middle of what we're doing to write down some of your own problems and try it just to practice along with it. All right, so make sure in the top blue box here you're going to put the example problems. The middle is going to be what steps you're solving, and then the answer is going to go in the bottom. I will give you 3 problems that I actually want in there, so make sure you're following along with this entire video. All right, so for exponent rules, this would be a great thing to write down in your notes if you don't already have it from the lessons. But we have a bunch of rules here, so just some things to remember. Anytime you have any number to the Sorry about that, I think I got disconnected there for a minute, but okay, so back to exponent rules. Anytime you have any number to the 1, that's saying they want that number 1 time. So that would just equal whatever you're raising there. And whatever that sound is, I think it's some ice maker in this room, so I apologize if that happens again. All right, any number to the 0 would be 1. All right, so I'm not really sure why it works out that way, but if you raise any number to the 0 power, it's just going to equal 1. All right, this is called a power to a power. When we're taking x to the 6th to the 2nd, what you're going to do here is multiply these 2 numbers. So you're going to take x and then 6 times 2, which would be x to the 12th. Okay, now when you're multiplying exponents, they have to have the same base for this to work. So these both have x's. If one was an x and one was a y, then we wouldn't be able to even combine these. But since they both have the same base, we can go ahead and do this problem. Whenever we're multiplying 2 numbers with the same base, we're going to actually add their exponents. It's supposed to be a positive plus sign there. All right, so we're going to have x to the 3 plus 2. So 3 plus 2 is 5, so it would be x to the 5th power. When we divide, we're actually going to subtract our exponent. So this would actually be x to the 3 minus 2, which would be x to the 1st power. And in this case, anything to the 1st power would just be x, but it wouldn't always work out that way. So let's just mark down x to the 1st power just so you know how it's working here. All right, whenever you have a negative exponent, to make it, you have to have a positive exponent to be able to work with it. So to make it a positive, you put a 1 on top of it in the numerator and you make it a fraction. All right? So this is an example here, and then down here we'll go ahead and solve this one. So if we have 2 to the negative 2, we want it to be a positive exponent. So remember, we're going to put a 1 on top, and then we're going to have 2 squared, or 2 to the positive 2. And in this case, 2 squared would be 2 times 2, which is 1/4. So 1 over 4. So that's how we would solve that there. All right, so those are some rules to just get you started. If you want to take a screenshot of this and print it out or just keep this in your notes, that would be a good thing to just remember. All right, let's do some practice. So here you see a big 1. That means that I want this problem to go on the first example problem on your reflection sheet. All right, so this problem here is showing, and actually I got a lot of these problems directly from your mid-module check, so you might actually see the same problem in your little in your lesson that you're going to do next. All right, so we said when we have a power to the power, we're actually multiplying these. So this would be the same as 4 times 4 times, or 4, oops, sorry, I put a 4 there. I meant to put a x there. Let me get rid of that. Okay, so we have 4 to the 4 times x equals 4 to the 32. So basically what that's saying is that's saying 4 times x 4 times something equals 32. So what times 4 equals 32? Well, I know that 4 times 8 equals 32. If I didn't know that, I could take 32 divided by 4 to figure that out. All right, so this is saying that 4 times 8 equals 32 there. So our answer here is x equals 8. So you'll put that in the answer box of your problem on your reflection sheet. All right, so remember here, whenever we are dividing, you're actually just going to subtract your exponents. So we have 8 to the 4 minus 2, which 4 minus 2 would be 2. So we have 8 squared. And a square means that we're going to multiply that base by itself 2 times. So we'd have 8 times 8, which is 64. So this answer would be 64, would be our final answer. Unless it's asking for we want it in exponential form. This is exponential form. All right, so we would leave it x squared if they wanted it like that. Otherwise, we would go ahead and solve it and make it 64. All right, this next problem. And guys, I have a lot of samples here. You don't necessarily have to put them on your reflection sheet, but this would be a good time to pause the video and go ahead and try to work these out on your own first to see how you do, and then come back and watch it to check and see if you got it right. All right, so this next problem, we kind of need to simplify this down before we multiply. So we've got 2 things going on. We've got a power to a power, and we've got a power to the 0. Remember on our last sheet we said anything to the 0 just equals 1. All right? Well, anything times 1 is itself. So do we even need to say 10 to the 8th to the 2nd times 1? No, we can actually just take this whole part out. All right? So we've simplified this problem down significantly already. So now we have a power to the power, and whenever we have a power to the power, we're actually multiplying. So we're taking 8 times 2, which is 16. So in this case, we have 10 to the 16th power. And we'll just leave that in exponential form like that. All right, so here's another problem that you might see on your mid-module check. Don't worry about variables. I know sometimes you guys freak out when there's variables here, but all we're looking for is to make sure the base is the same, so we're just going to keep that an A. And then remember when we're dividing, they have a division symbol here, but that is the same thing that we're going to do here. This is also a division symbol, so think of them as the same kind of thing here. So whenever we're dividing bases with the same exponent, we're actually just going to subtract our exponent, so n minus n. So we would just leave this as a to the power of n minus n. All right? All right. The next thing we're going to talk about is rational or irrational. All right? Rational means that if I solve it, it is going to, it's either going to stop or repeat. And I will explain what I mean by that in a minute. And then irrational means it's non-repeating. All right? So let's talk about what I mean here. All right, so you should have a square root button on your calculator. If you don't, you need to get one. If you're using the school calculator, remember you can change the view to be a scientific calculator, and then you'll find a square root button. So for this one, to figure out if the square root of 22 is irrational or rational, we're first going to need to solve square root of 22. And when I put that into my calculator, I get 4.690. All right? This number stops. If it didn't stop on my calculator, it would look like it's taken up the whole screen, and it would kind of like just round it at the end, in which I would know that that's irrational. But since it stops, I know that this is rational, so I'm going to just put a little r here. All right? Square root of 25. Remember, square root means what times what is 25, and we know that 5 times 5 is 25. So what times itself? So we know the answer to square root of 25 is just 5, which means it stops. So that would also be a rational number. Okay, anything over the 9 means that it's going to repeat forever, but let's go ahead and put that in our calculator. 1/9, we can also put that in our calculator as 1 divided by 9, which shows it is 0.111. So that is actually repeating. See how the same number is going on by itself? So this is a repeating number, so it's going to be rational. It's kind of crazy. I just did the next one, and we don't have any that are irrational, so I'm going to have to give you some more examples here. unless my calculator is just going ahead and simplifying them for us, rounding them. I might have my calculator set to do that. I'll have to check my work here in a minute. Okay, so the next one, when I put it in my calculator, 1 divided by 11 is 0.091. Again, it stops, so that would be rational. Now, why I'm kind of second guessing this problem is because I should have one that's irrational, because I think I just took this problem from the thing. So I'm going to pull up a different calculator, because I might have my calculator set to round, which I'll need to change the things on there. But if I do the square root of 22, oops. Oh, here we go. Yes? Okay, sorry about that interruption there. I had somebody come in my room, but I'm glad that I actually did this way because it shows you that sometimes our calculators aren't always right. I just checked all these problems, and I must have my calculator set to go ahead and round it, which isn't really a good thing. So I'm going to have to change the stuff on my calculator so that it doesn't round it for me. So when I checked these, the square root of 22, and I just used my school computer calculator to, my computer calculator to go ahead and solve these instead of the calculator that I have in hand. And this number actually goes on forever. So it's like 1, 2, blah, 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 blah. So it keeps going forever without repeating. So this is an irrational number, all right? When I do 1/9, I do get the 0.1 repeating, but remember it can repeat and still be rational. And then when I do 1/11, my calculator rounded that to 0.091, but it actually goes like this on my calculator, on a different calculator. So I know that 0.9 is repeating. So since that repeats, that's also rational. But sorry about that, guys. It just goes to show that it's good to check your work there. All right, so now I'm going to have to stop using this calculator for this next problem. All right, so this is number 2 for your reflection sheet. So make sure you're going to fill this out for number 2. So it says, which of the following is a rational number? So you can put this on the little problem, and then we're going to figure this out, which actually, we want the rational number. So we're going to have a couple irrational numbers on here. So why don't you go ahead and pause your video and see if you can figure this out using your calculator. Go ahead and do the square root of each of those numbers. Okay, so you should have already done the square root of each of these numbers to figure out what your answers are here. When I do the square root of 15, oops, I've got to put it in my calculator correctly. I get where's my mouse? I get 3.872 something, 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 something. So that goes on and on forever. So that would be irrational. Okay, when I do the square root of 16, some of these you should just know in your head, because if I know that 4 times 4 is 16, you're basically thinking about all your doubles when you used to multiply. All right, so I know that 4 times 4 is 16, so that square root of 16 is just 4. So here is my rational number. I'm guessing that we're going to only have one, but let's go ahead and check the rest of them. All right, so if I do the square root of 21, I get on my calculator, I get 4.58 something, 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 something. My calculator goes on forever, so that would be irrational. And square root of 22 would be the same as it was over here, but let me put that in my calculator again. I get 4.69, blah, 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 blah. Okay, so the answer to this problem would be the square root of 16. To show my work, I showed that I actually solved all of these to make sure that I was right. Okay, so make sure you put that on your reflection page. All right, and here is the third one we're going to practice here. All right, so pause this, give this a try, and then get back to me. And we want our answer in exponential form. All right. All right, you should have already tried this, but actually this was a trick question. All right, I don't know if you remember, but at the beginning of this video I said this only works, the exponential rules only work, you can only combine them if you have the same base. The base means the base number here, the whole number that's below the exponent. Those numbers are not the same, so you can't even combine them. If you wanted to solve this, you could actually solve this and get a real answer, but I asked you to leave the answer in exponential form. So the answer in exponential form would just actually be the same thing. So if you went ahead and solved this, let's go ahead and see if you would have gotten it correct. So we have 3 to the 5th. Oops, I did 3 to the 51. Let me get 3 to the 5th, which is 243. Remember, 3 to the 5th means I have 3 times 3 times 3 times 3 times 3. Okay? So I have 243, and then 5 squared means 5 times 5, which is 25. All right? So we can get a real answer for this. I would get 218. That's my real answer, but I asked you to leave an answer in exponential form. So for your reflection sheet, for the answer, you can just put that it's a trick question, that the bases are not the same. So we couldn't have done that anyway. All right, guys, that is all I have today, so don't forget to fill out your reflection sheet. And I'm sorry for all those interruptions that came about, but hopefully you understood this. If not, remember I'm available on Wednesdays during our virtual session time. You can join me there and ask any questions, or you're welcome to come to in-house, or let me know of something else that will work for you. Otherwise, thanks for watching, and I hope to see your reflection sheet soon.